Hello, this is Geometry, Notes 1-6, Day 2, two-dimensional figures. Or in other words, this is about area of similar polygons. Go ahead and do the warm-up ACT problem. Pause this video. When you are done, unpause the video and get your red pen so you can make red pen corrections. Go ahead and pause it. And here is the solution. X is 17, so the measure of angle 2 is 36 degrees. Make any corrections you need, and this is by using the supplement theorem because angles 2 and 3 form a linear pair. So by the supplement theorem, they add to get 180. Okay, let's make sure that you can fill out the table with correct formulas. So for instance, if on a rectangle we're using base and height, can you come up with an equation for the perimeter? For a triangle, if I have a non-right triangle and I have sides A, B, and C, can you come up with that perimeter? Let's say this angle is theta, or I have a triangle like here. Again, I have sides A, B, and C. Can you come up with the equations for perimeter and for area? And then for a circle, we have the radius. Go ahead and fill out the chart. Pause this video, and when you're done, pick up your red pen and check your answers. Okay, go ahead with your red pen, check your answers, make sure you're all good with perimeters and area formulas. Make sure you have both area formulas for your triangle. Last example, you are the manager of Pizza Pie Restaurant and are updating your prices on the menu. You want to have the prices of pizzas to be equitable, meaning you don't lose money when people buy larger pizzas. You looked online and saw that the price of a personal pan pizza at Pizza Hut sells for $3.50. So you want to sell your 8-inch cheese pizza for $3.50. How much should you sell your 16-inch cheese pizza for? Go ahead and pause this video and write down your answer. And the answer is $14. There are two explanations for this. Geometrically, we can see that if you are doubling your radius, you're really quadrupling the area. And you can see it pretty visually here. If you're taking that original circle and you're multiplying the radius by 2, it turns into 4 circles in the bigger region. You can also look at the algebraic explanation. The area of a circle is pi r squared, so if you're doubling the radius, you're really multiplying both sides by 2 squared. So in either case, you're quadrupling the area. Go ahead and flip your page over and go ahead and plot the 4 points on number A and number 2. And figure out what the perimeter and area are for those two problems. So go ahead and do 1 and 2. Pause this video. Okay, so both of these are rectangles. Number 1, the perimeter is 14 units. The area is 12 square units. The perimeter of the second one is 6 plus 6 plus 8 plus 8, which is a total of 28 units, and the area is base times height, which is what? Go ahead and fill that out. Okay, so the perimeter is 28 units and the area is 48 square units for number 2. So let's look at number 1 and number 2 and analyze these. These are both quadrilaterals. They're both rectangles with dimension 4 by 3 and 8 by 6. Note that the 4 and the 8 correspond, and the 3 and the 6 correspond. So the scale factor has been, or the scale factor has been multiplied by 2. And so therefore the perimeter has also been multiplied by 2. Whereas the area, you can clearly see 12 times 2 is not 48. It's been multiplied by 2 squared, or in other words, times 4. So when the perimeter or the scale factor has been changed by a factor of, let's say, r, then the area has been changed by a factor of r squared, just like in the pizza problem. Number 3, suppose the length and width of a rectangle are doubled. What effect would this have on the perimeter? That would just be the same amount times 2. Suppose the length and the width of a rectangle are doubled. What effect would this have on the area? Area would be multiplied by 2 squared, so it would be quadrupled, times 4. Suppose the length and width of a circle are doubled. What effect would this have on the circumference? Circumference is just like perimeter, so it's the same amount, times 2. And suppose the length and the width of a circle are doubled, meaning the length and width of a circle, you just think of it as your radius. Here's your radius, like your length times width. What effect would this have on the area? The area would be multiplied by 2 squared, or by 4. So area is always, you're going to square that ratio. Perimeter, you're going to keep that ratio the same. Okay, let's try one last problem. Go ahead and plot the points for number 7. Pause the video. Okay, you have created that rectangle. Now go ahead and with your red pen circumscribe a rectangle around the rectangle EFGH, and then count the dimensions. So we would have 6 here, 8 here, etc. Okay, so here are the dimensions, and to find the dimensions of our slanted rectangle, let's go ahead and use the Pythagorean triples like 3, 4, 5. So we have a 3, 4, and this is 5, and a 3, 4, and this is a 5, and then 6, 8, 10, because 6 is 2 times 3, 2 times 3, and 8 is 2 times 4, so it's still a 3, 4, 5, and 5 is 2 times 5 here. So this is a 10. So what we have is a rectangle with dimensions 5, 5, 10, and 10. So the perimeter is, go ahead and you figure that out and figure out the area. Okay, so the perimeter is 30, and you would have to write 5 plus 5 plus 10 plus 10, or any combination of that, like 5 plus 10 plus 5 plus 10. For area, you would have to give me the formula, base times height, which is 5 times 10, which is 50 units squared. Last problems, why don't you try to do numbers 8 through 11 on your own? Pause this video. When you are done, unpause it, and figure out if you're right or wrong. So get out your red pen when you're done. Oh, so if you have not done it yet, you have not seen the answer. So you're going to have to work with me on this. So if the length and width are halved, then the perimeter has the same amount, so times 1/2. And if the length and the width are halved, what would this have on the area? Well, the area is squared that amount, so times 1/2 quantity squared would be times 1/4. And suppose the length and width and height of a box are doubled, what would that have on the volume? Now, volume is 3 dimensions, so that would be times 2 to the 3rd power, which is 8 times as much. And then suppose the radius of a sphere is doubled. So again, a sphere is still 3-dimensional, so that'll still be 2 to the 3rd, which is times 8. Hope you enjoyed this lesson. It's a review of what we learned first semester, but it's a great real-world understanding, for instance, how much you should be charged for pizzas. Have a good time doing homework. Bye-bye.